Number 9 says 4 over 7b divided by 2 over 4b cubed. We cannot do a problem with division in it, so we change the division to multiplication, and when we do that, we have to take the next fraction and turn it upside down. So we're taking this number here, and we're turning it upside down over here. So all we've done is flip it. And now, what do we do? Are we adding? No. You find, when do you find a common denominator? When you're adding or subtracting. What do you do when you're multiplying? You cross cancel on multiplication. Okay, I don't know what the problem is, but lunch is over with. Put the food away. There's at least 4 or 5 people I've seen eating in the last 5 minutes. Put it away. You just came from lunch.
An hour ago.
An hour ago.
I don't have anything.
There's chicken on the
That's because you just finished it.
Chicken?
Both of you did.
Have you noticed how Rocha and Miguel eat orange juice?
Yeah, you glad you don't?
No, I don't. What? Check those. They don't have
I better not find anybody eating oranges in here.
Why not?
Because they're messy.
All I have is this. Doesn't prove anything.
Miguel? Stop talking.
Wait, we just recorded.
Yeah, we've been recording.
Funny. Can we continue?
Shut up,
I'm trying to.
Say YOLO, Mr.
So,
Say YOLO.
when we multiply fractions, we cancel. Now, when we cancel multiplication, we can cancel up and down, and we can cancel across. We call it cross canceling, but you also can cancel up and down. We've talked about that several times. We've done that every day for the last 2 weeks. Right? And all these problems, we cancel every time. We factor and cancel. We factor and cancel. Well, guess what? On this problem, you don't have to factor. There's no binomial. There's no addition or subtraction. There's no factoring possible. You simply cancel. What cancels?
4 and 2. I forgot I cancel.
2 goes on the 4 twice. The B cancels with one of these, leaving me 2. Anything else cancel? No. When nothing else can cancel, you multiply across the top and across the bottom. Across the top, we get 8b squared over 7. And we're done.
Was it 8?
All right, we're multiplying, which means it's really nothing but one big fraction. There's no difference between this problem and taking this line and just going straight across. You're multiplying it all together. So what do? We factor everything. We factor it. How do I factor the top?
30 yards. Oh, you have to 30 yards.
What's common?
No, but you have to put the R
There's
squared.
30R, and this is backwards. And the R squared is negative, right? So we're going to reverse this. We're going to take out 30R, but we also need to take out a negative because the big one is negative. So we're going to take out a negative 30R times, and we're going to write it backwards. We're going to take the negative 30R out of here. What's left? R. Take negative 30R out of here. What's left? Negative 1. Right? This is gone. Down here, what's common? 30R. So what's left?
Negative 30R. R.
No, because it's positive. This one's negative, so you take the negative out, so it'll be positive here. This one's already positive, so I don't touch it.
Would it be okay if we canceled it?
If you canceled what? Up and down?
Yeah.
I would think it's probably a bad idea.
Really?
If you're really careful, you do a couple things and you get away with it, you'll be all right. But what I'm afraid of is you get in a habit of canceling like that, and you're not going to bother about factor. You just start canceling stuff, and you're going to cancel when you should. If you factor,
No, but she's saying cancel right there. Yeah, like right there. That's where
these are not exactly the same.
No, but right now they are.
Now they are. But all I'm doing, once I start factoring, I don't cancel anything, I just factor. I factor everything. Then I go back and start canceling everything I can cancel. If you bounce back and forth, you get lost and you don't finish what you were doing. You leave something out. It's too easy to do it. I set it up, now I go and I factor every top, every bottom, that's all I do. I don't pay any attention. I mean, in my mind, it's not that I don't see stuff that's going to cancel, but I don't do any of it. I do all the factoring. How do I factor the bottom? How do I factor the bottom? I feel like about 5 of you actually are looking at me, the rest of you are not doing that, anything. You're busy talking or whatever.
R plus 6.
R plus 9. All right, what about this one? What's the trinomial?
You move
What are we gonna,
R.
how do we factor it?
You do the triangle, but it doesn't have a.
All I need,
R. So you
if
need
it
to
starts
put
with
R
1,
and
you
R.
go up and put your 2 parentheses in.
That's fine. 9 and 8.
So you got R signs, plus, minus 72, and 1, 9, and 8. Now everything is factored, right? Now I'll go ahead and cancel. Oh, I got R minus 1, R minus 1, R plus 9, R plus 9,
30R.
30R. So what do I have left on top?
Negative. You have
The negative, R minus 8.
And the 6.
And on the bottom, all I have is a 6, so nothing else cancels. So we end up with a negative R minus 8 over 6.
What about the square?
You canceled them.
What, that one?
Yeah, that one.
This whole thing's gone.
Oh, I thought it was canceled.
We factored it, it's gone. This is this. It's gone. Excuse me?
Like I did the same way, except I just flipped the thing over, and then I just took out the negative. Like for the top, for 30R squared minus 30R. Like for the top one,
Yeah.
I flipped it over, like I made it positive and just took out the negative.
It's the same thing.
That's what I'm telling you. That's what Melissa was saying.
I know.
Okay, say yes, no to me.
Ooh.
Damn.
What?
Security your life domain.
All right, here's 27. We have an equal sign. Remember, when we have an equal sign, we don't use a common denominator. It's not part of our answer. We just forget about it. We use a common denominator, but we don't write it down. We use it. So we skip the step of drawing the line and putting the common denominator underneath. We don't do that, which we do when we're adding and subtracting. So what's my common denominator? Well, what number do I have to have? I have to have a 5. Well, how many A's do I have to have?
2.
I have to have the most, which is 2. So my common denominator is 5A squared. So I write over all of them. And then I go back and do what? Right, again, I write them all over without stopping it, so I make sure I don't leave one of them out. I try to do all one thing at a time. Now we go back and do what? We go cancel. What cancels? A squared. What cancels? Everything. What cancels? 1 cancels with one of those, leaves me 5A. I do all my canceling. Now I go back and do all my multiplication. 5 times 6. Bring down the sign. All right, that's the problem. This is a negative. There's nothing here. This is a negative. This is a binomial, right? So you might want to put that in parentheses with a -1 in front because that's what you're doing. The negative has to apply to both of these. So we're taking the -1 times a minus 1, which is a -a plus 1, equals 5a times 1 is 5a. And now it, okay? All right. And now we just want to solve for a. What's the easiest way to solve for a here? Add a, right? 30 and 1 is 31 equals 6a divided by 6. 31 over 6?
Don't you do everything on one side?
Is that the right answer? Okay. But I did the common denominator, I cancel, I multiply. That gives me this statement. I look at this and say, I want to get a by itself. What's the easiest way to do that? Well, in this case, the easiest way is to move this a over here. Right? Huh? Well, when I get over here, I get 6a, then I can divide by 6. And when I get a and a number in front by itself on one side, I can divide by the number, and then I have the letter alone. I'm getting rid of all the addition and subtraction. (23). We have 4 fractions inside of a fraction. Now, I did one of these at the end of class yesterday, right?
No.
All right. The easiest way to do this is look at all the denominators. Look at the denominators. Look at all the numbers. What's the common denominator between 3, 4, and 6? 12. Right? 12. So I needed 12 in my common denominator. What letters do I need? I need 1x, right? So my common denominator is 12x. I need the common denominator for all of the numbers, and then for the letters. The letters all have x, so that's what I need. So it's 12x. Put in 12x above this fraction, put it above this fraction, put it above this one, and put it above this one. What do I do with common denominators on top? I cancel. So I go there. I can cancel the 3 with the 12. 3 goes in the 12 4 times. 4 goes in the 12 3 times. 6 goes in the 12 2 times. The x cancels with the x. I cancel. Now I go back and do what? I multiply. What do I get when I multiply over here? 8x. Keep the sign. What do I get when I multiply here? 3x. Over. What do I have down here? Minus 2x. Is there anything that I can do that simplifies this? Do what? What? I don't want to factor.
Oh no, you can't do anything else.
What's 8x minus 3x? Aren't they like terms? I put them together. So this becomes 5x.
Can't do anything else.
Now, can I cancel this x and this x? No. Why not?
Because it's a binomial.
This is part of a binomial. Can I cancel part of it? Does 5 go into these? Can I put 5 into 12 or 2? Why not?
Because you're supposed to take out something from both of them.
1, they don't go in. 2, if they don't go in, and they're not common. There's nothing to cancel. 5 doesn't go into it. So we're done. There's my answer.
We need to take out like the 2 from the bottom.
What am I going to take it out with?
2, then 6 minus x.
Common denominator is 60. 3 times 5 times 4. Put it on top and do what? What do we do now? We cancel. Every time we put the common denominator on top, we do it so we can cancel. That's why we pick it out. What cancels? 3 in the 60? 5 in the 60? 4 in the 60? What's left? 20 times 33? 660? Minus 12x over 15x squared. Well, there aren't any letters common, right?
No.
Because this one doesn't have letters. So, what numbers go into 15?
3.
3 and 5, and that's it, right? So if anything can be taken out, it's going to be a 3 or a 5. Does 5 work? No, because 5 doesn't come out of 12. So if there's something common, it's 3. Does 3 go into 660? Yes. Does it go into 12?
Yes.
So I can divide everything by 3. How many times does 3 go into 660? 220. Minus 3 into 12 over 3 into 15. Okay? Okay, the way I showed you yesterday is to find the common denominator of all fractions. Where's my big, the whole thing's a big fraction, right? Where's my division line?
Big one.
This one, right? So what's my denominator here, 15?
No. 8.
Over 1.
It's over 1. These are fractions. This needs to be a fraction too. It's 15. That's the numerator. It's 15 over 1. What's my common denominator?
Looks like a T.
A squared.
15a squared. 15a squared.
It's 15 in the denominator. No.
Oh, that's the top.
Fraction, fraction, fraction.
No wonder.
Fraction.
Okay? Yeah, and that's the biggest problem with this one is realizing that the 15 is the denominator of the big fraction, but not a denominator for the small one. We want the common denominator for these small fractions. And this one is 15 over 1. Okay? If it was on 15 was on the bottom here, they would have to have something over and then line and then 15. So, I don't care about the 1, it doesn't affect the common denominator. So I have a and a squared, so my common denominator is
A squared.
a squared. What do I want to do with a squared?
Put it on top.
Put it on top of every fraction, including this one. What do we do after you put the common denominator on top?
Cancel.
Lunch is over with. Do not eat in this class.
What do you mean? Claudia?
We got that.
Excuse me.
You're recording them.
I know that.
I think I'm gonna edit it out.
Now, once I put it on top of everything, we go back and do what?
Cancel.
We cancel. We cancel the bottom number, the denominator of each fraction, with its common denominator. These cancel completely. Here I have an A. It cancels with one of them, leaving me 1. Down here, nothing cancels. After we cancel, what do we do?
Multiply.
We multiply. What do I get when I multiply? 15A. Keep the sign. 15 over 15a squared. That's my answer if I cannot reduce it down any further. What do I do to check to see if I can reduce it down any further? Is there a common factor in every part? In here, and in here? If there is, then I can take it
I
out.
know what you do. You can take 15.
There's a 15, a 15, and a 15, so it's common. So I can divide all of them by 15. So what do I get? A minus 1 over a squared. Just my cancel with 15. Can I cancel this A with this A?
No.
Why not?
Because
doesn't part.
The top one.
One doesn't have it.
This is a binomial.
You can't.
You cannot cancel part of a binomial. That A is a part of a binomial. You cannot cancel it. You can only cancel A minus 1. You don't have an A minus 1 at the bottom. This is our answer. Number 30, we have a bunch of binomials and trinomials, right?
Yes.
What do we have to get in the problem?
Factor.
Let's get the common denominator, and to do that, we need to factor the denominators. We're actually doing common denominators unless we see something that.
Where I got the wrong.
That was my board.
Now, wherever we were at.
World War War? We
Um,
haven't even started.
I know. All right, so we need to find the common denominator. When we have binomials and trinomials, Josh, turn around. Then we have to factor the bottoms. When we're doing common denominators, basically you don't have to worry about factoring the top because you're going to multiply and combine like terms after you multiply. And so unless you can see there's something that's going to actually cancel, it has to be in the same fraction. In other words, I can take a 2 out of here and take a 2 out of here. Can I cancel those? No, because they're not in the same fraction. And we got equal signs or pluses between them. So they still don't cancel. So I don't need to worry about the top. We just do the bottom. Can I factor this one?
No.
Can I factor this one?
Yes, sir.
Yes. Trinomial.
First of all, it's x squared.
Okay. So what do we get? X and X, plus and plus. What gives me 6 and 5?
2 and 3. 3 and 2. Whatever.
3 and 2. What about 6 and 5? 6 and 1.
No.
What's 6 minus 1?
5.
5. So
But there's
that
no
works,
minus.
But
right?
it's plus.
That's right. You're adding. You have to add them. You can't use 6 and 1 because you have to subtract to get 5. And that's a plus, and so subtracting isn't an option. So there's a couple numbers like that. You actually get this by adding or by subtracting. But you have to use this method to get it. So you have to add in this case. Okay, so this is gone. All right, what about this one? Can I factor this one?
Yes.
What?
X per 2.
2 times.
X plus 3.
All right, that one's gone. All right, now.
There's
there's
another
a-
parentheses.
Okay, now, there's an equal sign, so we don't need to draw a line and put the common denominator underneath. We just need to find the common denominator. So what do I have to have?
Can't you just factor out the top of it?
It doesn't do anything for you. You factor out the top, you have to turn on, multiply everything on top, right? If you factor, you got 2 things to multiply, two more things to multiply rather than 1. It doesn't help you to factor the top when we're adding and we're doing common denominators on the bottom. It actually makes the problem longer. Unless you can see that something is actually going to cancel. For instance, if I get x plus 1 down here, then I'll jump up here and factor the 2 out, take x plus 1 here, and cancel them. But I don't have an x plus 1, so that's not going to work.
All right, next.
All right, so what's my common denominator? What do I need?
2.
Well, I need both of these, right? So I need an x plus 3, and I need an x plus 2. Is there anything extra here? Is there anything extra over here?
2.
The 2. So I need a 2 also. All right, so there's my common denominator. If I look, is this up there? Are both of these up there? Are both of these up there? So I'm ready to go. So this is going to cancel. What's left?
Nothing. 2.
This cancels with this. What's left up here? 2 times x plus 2. Here, these both are going to cancel up here. What's left? The 2. Over here, this is going to cancel up here. What's left? The x plus 2 is left. So this is what's, if I write the whole thing out 3 times and cancel, these are the ones that don't cancel. So now I don't need any of this anymore. And now I go back and multiply. Now we're not doing this. This was to help me find these. So that's gone too. So what's left? 1 times x plus 2. So that is 2x plus 4. plus
4x.
2 times this one, right? 4x plus 4 equals 1 times that.
X plus 2.
Now, I now need to solve, right? And in this case, there's no squares, right? So x's go on one side, numbers go on the other side. So what I'm going to do is move the x over here and subtract x. 4 and 4 is 8, and it's going to the other side. So
Why don't you combine like terms first?
then I have to do it twice.
No, you don't.
If I combine these, then I rewrite the problem, and then I have to move these over and do the same thing. So I'm just moving it over now, and now move this over there, and these are gone, right? And now what do I have? 4 and 2 is 6, minus 1 is 5. Try it the other way. I guarantee you can't do the other way as with as little writing as I did.
I got it.
You actually have to do 2 complete steps otherwise. I want to move the x, that x over here, I add the numbers together, move it over there, and then I just add the x's here, and over here I add these together, and I get negative 6. And now I divide by 5. Chris, way to do it. And you say, I'm confused. Don't do it that way, do it the other way. That's fine, it works. You're going to do the
I
same
have a
thing.
question.
Question on this, hold on, wait.
No, wait, it's on that. Don't you have to fight that?
Extraneous solutions. What are the exclusions?
The ones that are in the parentheses,
What's the exclusion for this?
x plus 3, negative 3.
Negative 3. X cannot be a negative 3. That's that one? That's that one. What can x not be?
Negative 2.
Negative 2.
If we don't put that on a test, are you going to correct it wrong? Really?
What can this be? Negative 3. So we're done. Those are exclusions, right?
2 is in the 0.
Here's what you have to do. No, there's no 0. You have a 0 when you have an x out front. The 2's not an x. If there's an x out front, it's 0. When is 2 equal to 0? Never. So you don't use numbers up there. Now, these are the exclusions. You do need to do it because do either one of these show up down there? No. So it doesn't matter. We're done. If this also had a negative 3 down here for an answer, what does this say? X cannot be a negative 3. So it overrides this, and you'd have to take this and cross it out. If you checked your answers, this wouldn't be there. If it's an exclusion, you cannot use it in the answer. So anything that shows up here that's also down there has to be crossed out down there. It cannot be in the answers. And that's why it's what? Because on the last assignment we did 2 days ago, I think, there was 4 or 5 of them that one of the exclusions showed up down here, and you had to cross it out. You need to have them because they give you answers that don't work. They give you answers that are perfectly good answers, except they don't work in this problem. So you have to cross them out. Any number here in the exclusions have to be crossed out of the answer. Okay, 20. What do we have? You can do it exactly the way I showed you earlier and yesterday. What's the common denominator? 5 times x minus 1. 5 times x minus 1. What cancels?
5.
Right? Now multiply. Over what? X squared times x minus 1. And then you could say x cubed minus x squared. So either one of these I would accept as the denominator. We're done. That's it. All right, we're adding. What do we have to have every time we add? Common denominator. Now, is there an equal sign? No. So that means I have to draw the line and put the common denominator underneath. It's part of my answer. So what do I have to have? What's the common denominator between 6 and 3? 6. How many x's do I need? That one. How many y's do I need? I need 2 for here. That's it. The 3 is inside the 6. It's part of the 6. So I don't need, this is what I need right here. Right?
Yes.
Okay? So, what am I going to do with this? Put it on top. What do I do next?
Cancel.
Cancel. Cancel. Everything cancels. Oh, here what cancels? 3 goes into 6 twice.
Cancel.
Now what?
Multiply.
I multiply. Well, that canceled. All I have left is this, right? So I have x minus 4y plus what?
8x squared.
4 times 2,
8.
right?
So 8.
So it's 8.
8x
How many x's? 2. 1 here and 1 here. X squared, y squared.
Y.
Obviously, nothing's common because this has an x, this has a y. They don't have the other one, so there's nothing common. We're done.
That's your answer?
That's your answer.
Okay, me and Anna.
Common denominator, cancel, multiply. And there's anything else to do. You mind like terms or I do?
Record.
13. What should I do first? No.
Factor.
The answer is yes, but no. I can do something first before I do common denominators that makes the problem easier. Do I have a 4 on top and a 4 on the bottom? Now I can't cancel. If there was a 4 here and here, they don't cancel. But these are in the same fraction. I can cancel them in the same fraction. They cancel. It just eliminates part of the problem.
It doesn't matter whether they're multiplying or adding. We can still
Yeah.
cancel up and down.
If that's all I have, would they cancel?
Yes.
Sure, right? So it doesn't. The fact I'm adding something to it doesn't change the fact that this fraction can be simplified.
Yeah, but
Doesn't matter whether we're adding, subtracting, or multiplying.
Alright.
A single fraction like this can be reduced, no matter what you're doing. So what's my common denominator now?
6x.
6x. What cancels? 6's over here. The x's. What's left? Multiply. X times x minus
Line.
x times y plus 6y. Is there anything I can put together on top?
Nope.
Is there anything that's common to everything that'll cancel?
1.
That's it?
No. There's an x here, here, and here, but there's no x over here. So, nothing you can do with it.
So that's it?
That's your answer. All there is to it. Okay.
About how long
Mr. Greeno,
Okay.
is it true that your hair grows every 8 inches? I mean, every, every
I'm
day
pretty sure it grows 8 inches if you don't cut it.
for every day 8 inches?
It takes
I mean,
3
8
8 inches every day?
8 centimeters.
I don't think so.
It takes 3 months to grow an inch.
Él me mintió, un babado.
Okay, here's 11. 11 is a division problem. We don't do division.
We do multiplication.
We do multiplication.
So you switch it.
So we take the division sign and we make it a multiplication sign, and we take the fraction and do what?
Flip it.
Flip it over. Put b minus 2 on top and b minus 10 on the bottom, because we turned it upside down. We inverted it.
Yeah.
All right? So now we do a multiplication problem. What do I have to do next?
Factor.
I didn't hear anything. What do we do next?
Factor.
Factor what?
The triple.
When we're multiplying, we factor everything.
He does like the girl.
So this has to be factored. So it's a trinomial. We have what? V and V, negative and negative. Now, what two numbers give me 90? When I add them, I get 19. 10 and 9.
Mr. Green, why negative?
What does this sign tell me? No. What does it tell me about these two signs?
That they will positive.
They are, if it's a plus, they have to be the same. And this one always goes in the first one. So if this is a plus, these two have to be the same, and this one has to be negative. So that one has to be negative too. A plus. How do I get a positive 90? By two negatives or two positives, right? They have to be the same. They cannot be different. This one always goes here. This one says the same, then I take this one and put it over there. If this one was a plus, I put a plus here. That one says the same, this would be a plus also. Now what cancels? V minus 9s, V minus 10s, and let's see what. And what's left?
You made it 2.
Yeah.
V minus 2 or 1?
V minus 2. Quiet, please. What am I looking for here? Common denominator. What's my common denominator for numbers?
25m squared.
What numbers do I need in my common denominator?
25, 3 and
25 and 3, right? So what's my common denominator for number? 75. Because I need 25 and I need 3, and the 3 doesn't go into 25, so I have to multiply them together. How many m's do I need?
2.
I need 2 for down here. So 75m squared is my common denominator. Put it on all of them. And now I go back and what? Cancel. The m cancels with m squared. 25 goes into 75 3 times. 3 goes into 75 25 times. And the m squared is canceled. Okay, go back and multiply. 75 times 9. That's 7, what is that? 675? 675 plus 9 times 3. M. Okay. M. 9 times 3. 27m squared. Bottom. 25 times 2.
50 times 2.
M squared. Plus 25 times 75.
Big number.
87.55.
What is it?
1,800.
75 times 25?
Bailey.
1,875.
1875? I didn't hear you. Alright. Do we have an M in all of them? No. Don't have an M down here, so none of the M's can cancel. Now the question is, do I have a number from all of them?
1.
Well, what goes into 27? 27 is the smallest one, right? What goes into 27?
9.
Nothing but 3s. 2 3s, so that would be a 9, but all you really were, let's do 3s. Well, does 3 go into 50 evenly?
No.
If 3 doesn't go in, does 9 work? No. If 3 doesn't work, 9 can't work because 9 is nothing but 2 3s. So, only 3 works here, but 3s don't work here, so nothing works. We're done. That's our answer.
That's all right.
7 p.m.
Nothing, there's nothing to reduce. Now, you can take and reduce these simple, you can actually factor all these down, but nothing's gonna cancel out.
There's no common
So you can
denominator.
factor in nothing but cancel out.
When you do this, I have a problem, this is all you have to do.
All we have to do, and
We're done.
then we're done.
There's no common denominator?
I was just asking.
Why?
Because the,
When you
One more?
put these together and turn it up, bring it up here and turn it upside down, this is gonna cancel with it down there, they're gonna go away. So, we just ignore them, we just, if we do this, they just don't show up, we end up with the answer.